Hi, this is Mrs. Erickson, and this is Dr. John. This is a new installment of
Please try this at home. Science experiments. We have 2 rules for you to follow. Number 1, have fun. Number 2, always ask your parents before trying these experiments. Now, let's have some fun. Okay, today's experiment is one we call
tie-dyed milk.
For this experiment, you're going to need some milk, some dishwashing detergent, and different colors of food coloring. We're going to explore an idea called surface tension. First, we're going to pour some of our milk into a bowl, just enough to get a nice surface. Now, we're going to carefully put drops of each color of the food coloring. We don't need that much. We're going to do 4 drops. Now notice how the colors are staying put. They're not spreading out. The green spread out a little bit, but they're holding in place. This is due to an idea called surface tension, where the molecules of the milk are grabbing onto each other so tightly that they're preventing the molecules of the food coloring from spreading. Now, did you see that? What happened was the dishwashing detergent broke up the molecules, they separated them out, which immediately allowed the colors of the food coloring to spread out. And this caused all of this swirling that we see of all the colors, just like a tie-dye t-shirt.
I think we should try some different types of liquids.
Okay, let's try another kind of milk that's much heavier, cream.
Sounds good.
All right, so here we have some heavy cream that we got from the grocery store. It's fresh. Let's pour a little bit of this into our bowl of science. And now let's take our food coloring and make. You don't need a lot. You just need a drop or 2 each. Look at how the colors just sit there. The surface tension in cream is very heavy and strong. Look at those. We just have small dots, not doing anything. But let's take some of our dishwashing detergent. Look at it spread. Look at that surface spread out, and it's pushing against those drops. Let's do a little bit more, see if we can make it push in another direction. That soap really pushed against it. Not much seems to be happening, but if you look close, under the surface, things are happening. Look at how the green is spreading seemingly from underneath. We need to keep watching this because I think surprising things are going to happen. Look at how it's streaming. So there are things, look at how the red popped up from underneath. So there's things happening under the surface that we can't see. This is very cool.
One more. Let's try skim milk.
All right, so this is thinner than whole milk. So I'm wondering what it will do. So here we go. We've got our skim milk. We'll put it into another bowl of science. You can already see it's thinner than the other milks. And we'll do 1 drop each. Look at those drops spread out a little bit more because there's already less surface tension with the skim milk. 1 drop each. Here's our green. All right, there's already a little spreading happening, but let's take our, ooh, that spread out so quickly. So that spread out faster than the whole milk and a lot faster than the cream. And it's already swirling around. That's very cool. So we'll set that aside next to our other two, and we'll compare them. And we've got one more surprise for you after this. Okay, so now we're going to compare. These have all been sitting here for a few minutes. We had cream, we had whole milk, and we had skim milk. The cream is the thickest, the skim milk is the thinnest, and the cream had the thickest surface tension, followed by the whole milk and the skim milk. And if you remember, the drops spread out much more slowly with the cream. Then the whole milk, they spread out pretty quickly, and with the skim milk, they spread out very quickly, all with the help of a few drops of the detergent.
Something I noticed, Dr. John,
What's
is
that?
this cream seems to still be changing and moving around. I wonder how long that will go on for. And is that because of the higher surface tension than the other two milks?
I wonder, it also looks to me like there's things going on underneath the surface of the cream, almost like a volcano burbling up.
So it might be kind of cool to try this in a glass jar or a glass cup and see if we can see that movement from the outside of the glass.
So we can see what's happening underneath?
Yeah.
Let's try that. Okay, so we think we might be able to see things underneath if we use this clear glass. So now we're going to repeat the experiment using whole milk. We're going to carefully put a few drops in. And we already see that things are happening. And let's put a drop of the detergent in just to shake things up. Can we see things happening underneath? It looks like we can see things on this side a bit. There's lots of swirling. Look at it, goes all the way down to the bottom. So there's, just like there's swirling on the top surface, there's swirling happening throughout. And here's the back side. Here's the red. Look at that swirling that you can see. And it just keeps on going. So even when it looks like it may have stopped, when you look at from the top down, you can see that it's still swirling underneath. There's still gurgling. Look at it over here in this corner. There's still things happening. That's pretty cool. And that's all due to the detergent breaking up the surface tension, allowing the molecules, or forcing the molecules to spread apart when they really want to stick together, and just causing them all to mix up. And the food coloring just shows how everything is mixing up.
So that's our tie-dyed milk experiment. I hope you enjoy this experiment and you try it at home. It's really kind of cool.
Have fun.
Bye.